Hi, this is Mr. Seitz, going to help you with number 4 and number 5 on the Unit 5 quadratics review. So number 4 asks us to find the y-intercept of the graph y equals the quantity x minus 8 times the quantity x plus 3. So to find that, the y-intercept happens, or the y-intercept can be found by setting x equal to 0. So all we have to do is plug in 0 for x and solve what y would be. So I've rewritten the equation, and I'm going to let x equal 0. So if I plug in 0 for x, I'm going to get y equals 0 minus 8 times 0 plus 3. So that simplifies to y equals negative 8 times positive 3, and negative 8 times 3 gives us negative 24. So y equals negative 24 when x equals 0. So therefore our intercept is negative 24 for the y-intercept. So on number 4, we can find negative 24 on our worksheet. It's going to be option D. So number 4's answer is D. Moving on to number 5. It says the function y equals negative 5x squared plus 4x plus 7 is, and then it gives us some options about concavity and whether or not there's a maximum or a minimum. So let's write down the equation for number 5 and talk about that. Number 5 here, to know if it's going to be concave up or concave down, we need to know what the a value of our equation is. So our equation, let's see, okay, so this should be y equals here. So we've got y equals negative 5x squared plus 4x plus 7. Our a value is going to be negative 5. So a is negative 5. If a is greater than 0, then we know that we would have concave up. If a is less than 0, then we have concave down. Well, in this case, a is negative 5, so if a equals negative 5, then a is less than 0, and the graph is concave down. So concave down is going to look something like this. Concave down kind of looks like a frown, or in my classes we've talked about it looking like a mountain or possibly even a rainbow. But just know that this is the general shape. If this is our x-axis and y-axis, this would be the general shape for a parabola that is concave down. So looking at that, we see that something that is, or a parabola that's concave down, that's going to have a maximum. It's going to have a point up here that represents the highest y value of our function, and that's going to be a max value. So we know that number 5, the equation is concave down and it has a max value. So let's go back to our worksheet here. We're looking for options that are concave down and maximum value. That would be option C. So there we have it. The answer for number 5 is C, concave down and has a maximum value. I hope this has helped you for number 4 and 5, and best of luck for your studying and test on quadratics.